Hello, we are in our last objective for section 2.6, and our last quadric surface is a cone. So a cone or elliptical cone would have one of these forms. Notice it's slightly different. It looks kind of close to a hyperboloid, except the right hand side is 0. That allows you to move one of the variables over to one side and then the other two variables to the other side. And now it kind of looks like a paraboloid, except the z here is squared. So those are little things to distinguish between the different types of quadric surfaces that we've studied before. And here it says the orientation can be switched if you change the z variable, or the variable that either has a negative if it's in one of the standard form where it's equal to 0, or if we bring that variable over to the other side and then the other two variables are positive. Then here we have our cone. So our cone can sometimes this cone has both the positive and negative parts. So let's simplify and suppose we have a cone that looks like z squared is equal to x squared plus y squared without any variables. So this is our simplest type of cone. And if we take the square root of both sides, z is going to be either the positive, the square root of x squared plus y squared, or z is equal to negative, the x squared plus y squared. And so this first example of a cone would be a cone that has both the top and the bottom. I think we called it napes when we were studying the conic sections. And if we just want the top part, we can take a look at this and say, let's take the square root of z squared, and then the positive part would be the top part. And if you just want the bottom part, then we can take the negative of that z squared, and then here you have the bottom part of the cone. So that's how the cone would look like. So in our example, we'll look at this cone, and we'll see that if z was equal to 0, you're going to get x squared plus 2y squared is equal to 0. And because the other side is equal to 0, the only way that this will work is that if x and y are both equal to 0, so you really just have the origin. Now, if you let z equal to 1 or negative 1, z is equal to 1, you get x squared plus y squared, or that's 2y squared, minus 1 is equal to 0, so we'll bring the 1 over, and then you get x squared plus y squared, 2y squared, is equal to positive 1, which is an ellipse. And so here now it starts taking an elliptical shape, and so that's why sometimes this is called an elliptical cone. And so this is happening for z is equal to 1, but it also would happen when z is equal to negative 1. So we get that symmetry of the shapes, and the shapes would look like elliptical cross-sectional cuts. So if we take a cross-sectional cut, we get ellipses in the top and in the bottom. So that's generally how these cones would look like. And I don't have another example ready, but let's say you had x squared is equal to y squared plus z squared. Let's do this in a different color. If you have one of those, then we can imagine that our orientation is going to change. So now, instead of running along the z like we had before, we would draw our xy Z space over here, and now we're going to be opening up along the x-axis. So we can imagine the cones opening up along the x-axis, and since we're talking about the two-sided cone, we can think about the cone opening up in the back side as well. So that's our quick overview of our last quadric surface, which are cones, or elliptical cones. All right, I hope that helps. Good luck.